Okay, so before we dig into log, okay, notation, okay, let's talk about something else first to help you understand what's log about, right? So for example, if I have 2 cubed, right, everybody knows that is equals to 8, right? So if we are looking for the answer equal to 8. Now, if I do something backwards, okay, I have, let's see. If I want to solve for example, so right now, okay, let me erase that, okay? So if you get this question, right, everybody knows it, right? 2 to the cube is 2 times 2 times 2, so x equal to 8. Now, if I put the x at some other place, okay, and I say x cubed, right? So you're missing the base now. And what does, and it equals to 8. Okay, so how do we find the x then? This is a simple question, right? So Donna, what do you think? What's the x?
2.
Yeah, x equals to 2 for sure, right? And then we can use a symbol to help us get rid of the cube, right? What symbol would that be? Ray?
What?
How do you get rid of the cube to find the x equal to 2?
I mean, you just kind of mix and match your options and then find x equals to 2.
Oh, like guess and check?
Yeah.
Okay, well, guess and check can work here because it's 8, right? 8 is pretty easy to find, but what if it's like 8, 9, 7, 1, 2, right? How do you find the x then if it's something like that? How do we do that? Anyone?
You make 2, 8 equal to same base. You do the same base thing.
But I'm talking about the second one, the bottom one, right? There's no base. We are looking for the base though, right? We can only change to same base if both left and right side they have a base, right? Then I can make both sides become base of 2, right, or something. But right now we are missing the base. So how do we find the x in this case? Cindy, what do you think?
Use log.
We haven't learned log yet.
Oh.
This one you know how to do it. This is
Use cube root.
which one?
Roots.
Roots, right? Yeah, so
Yeah.
something you already learned, okay? We didn't learn log at all. This one doesn't need log, okay? We just get rid of cube by using a cube root, right? So your x will equal to cube root of 8, okay? So let's erase the middle part over here, okay? We have two expressions here, right? We have, and then let's get rid of the variable 2, okay? So the x we found out is equal to 2, right? And 2 cubed equal to 8, okay? So what's the point I'm trying to make here? Both of them actually do the same thing, right? They both of them are equal. Both of them are using the same numbers, but they are expressed in different ways, right? The first one is isolating the 8, right? 8 is by itself. The second one, the 2 is by itself, right? 2 equals. The other one is 8 equals. So each one of them is isolating different parts, okay? But then they are in the same, they are all using the same number. So same with log, okay? So the cube root is to help us to find, okay, we can write it down, find the base, right? It helps us find the missing base, okay? Now for log, is going to help us find the log. We can write it down. Log is to find the missing exponent. Okay, so it's just a new notation, just like cube root. Cube root can help us find the base, right? Get rid of exponent. And then log is another symbol that can help us get rid of the base and then find the exponent. Okay, so different purpose. Okay, log is to find exponent. Cube root is find the base. Okay, so just a little introduction on the side. So we need to get used to this new symbol. Okay. So just like number 1 and 2, right? I can, because you guys are already used to this. So that's why this looks very easy to you, right? Cube root of 8 equal to 2, 2 cube equal to 8. So you can go from number 1 to number 2 easily, right? So now we want to go from number 1 to number 3. Number 3 is using log, okay? To express in log, okay? Using from exponential, okay? So let's take a look at the definition now. So here I use 2 cubed to the equal to 8 again, right? So look at, I'll highlight this, right over here, 2 cubed equal to 8. So if I want to rewrite, right, rewrite into the log form, okay? This is the log form. The left side is the exponential form, right? Because you have exponent, right? Just like the example on the top, the number 1 is exponential, number 2 is the radical form, right? Number 3 is what we are learning right now, okay? Log form, exponential form, okay? So to turn this into log form, remember our goal is to solve for the exponent. Okay, let me erase the highlight here. I'll just highlight the exponent. Okay, so our goal is to isolate exponent. So what you will start with, you see the arrow, right? You start with the base. You write the base first. You write log and then write the base. And then you follow this counter clock, right? Think about the clock. The clock, counter clock, you go this direction, right? So you go to the other side of the equal sign and you'll see the number 8. So the second number you write is 8, okay? And then finally, you write a 3. So that's the third one. Okay, I'll explain one more time, okay? Let me erase this again. Okay, our goal is to find the exponent, all right? So you will start with the base. And the base, you put it here, okay, on the log side, okay? So that's called the base. And then you go counterclock, go to other side. So the second number you write will be 3. Sorry, the 8, right? Second number will be 8. Right? Second number. And then the 3, you will put it on the other side, equal to 3. So for example, okay, so let's say if I have 4 squared equals 16, right? So I will start with 4. So I will write log base 4, right? I will write 4 first. And counterclock, I go to other side, I'll write 16, right? And then finally, I'll write 2, so equal to 2, okay? So this is just a new symbol that you need to get used to, right? How to change from exponent to log form, okay? But they all mean the same thing. The purpose is to find the exponent, right? You see the exponent is 2. So now 2 is by itself. All right? So I would like you to try this one first, okay? Change to log form, okay? Question 11, all right? So each of the 4 questions, A, B, C, D, please change them to log form. So when you finish changing, please raise your hand, okay? It's the same idea when you learn the cube root, right? It just takes time to get used to it. Does anyone have questions? Okay, let me know anytime, okay? If you want me to explain any part in the examples. Okay, when you finish writing the for log form, please raise your hand. Okay, so each one will have log something of something equals something, okay? So the main concept you need to remember is log is to find exponent, right? It helps you isolate exponents, okay? That's the whole purpose of using log, right? So let's check the first one, okay? Tiana, how do you write this out?
Log 2, 1 over 16 equals to -4.
Yeah, okay. Now we also need to know how to say this properly, right? Because all the numbers are together. So when you say the first one, you can say log base 2 of 1 over 16, right? Instead of log 2, 1 over 16, okay? We'll say log base 2 of 1 over 16, and then equal -4, okay? So let's try question B. Ray, how do you change that one?
Log with the 8 and then
Base 8.
what?
You have to say base 8.
Base 8
Yeah,
of 1
yeah.
equals 0.
Yes, very good. Okay, let's try question C. Cindy?
Log base 2, 7 equals x.
Of 7. Okay? Yeah. Of 7 equal x. Okay. Last one, question D. Eric?
Log base 3 x plus 1 equals 5 plus x.
Okay, okay. So remember to say of. Okay, log base 3 of x plus 1. All right, now we need to know how to go backwards too, right? Just like if you have cube root, right? You need to know how to go back, right? Cube root, the opposite will be cube, right? So same thing here. We want to go back from log form, right, back to exponential form, okay? So the way to do that is also counterclock, right? So I will start with the base again, right? See the green underline, okay? I will start with the base. So the base will be 2, right? And then you go to counterclock, so go to the other side. And remember, the other side is the exponent, so you will write 3, right? And finally, equals to 8. Okay, so the example we had above, okay, let me erase this part, right? So we are starting from the log, right? So you start with base 4, so you write 4, right? To the exponent of 2, so I write 2, right? And then equals to 16. Okay, that's how you go from log into exponential, okay? You also do counterclock. So that's why down here, I put a sentence here, right? Counterclock, you can change the log, okay? Change between exponential and log form. All right, so remember, just always starts from the base, right? You have the base in exponential, you also have the base in log form. So please try the following 4 questions as well, okay? Change to exponential form. When you finish, please raise your hand. Start from the base, right? And then, right, counterclock, okay? From log form to exponential, from exponential to log form. Doesn't matter, it's always counterclock, starting from base. Okay, please raise your hand if you're done. Okay, you ready? What's the first one?
5 to the power of 1 equals to 5.
Yep, very good. Okay, Cindy, second one.
10 to the power of 0 equals 1.
Yep. Okay. Tiana, do you have any questions? Okay, can you tell me answer for C?
X to the power of 5 equals to 3.
Yeah, very good. Okay, you don't need to solve it. If you want to solve it, you can use the root, right? But here we are just changing to exponential form. Okay, Eric, last one.
10 to the power of 3 equals x.
Yeah. Okay, so now you are used to the symbol, right? So we can, but of course you are more used to exponential. So usually if you get a question that has log, we'll try to turn it into exponential. And then once you get the exponential form, right, then you can use what we learned last week, right? We had same base, try to make it same base, and then solve for the unknown, right? Solve for the exponents, okay? So knowing how to change to exponential, and then you apply same base, okay? We'll try a question on the next page. So the first kind of question is, all of them is solving for x, right? But then they are in log form, okay? So not very friendly, right? We're not used to log. So we'll change all of them into exponential first, right? So what's the exponential for question A? Cindy, how do you write this one in exponential form?
X to the power of 4 over 3 equals 16.
Yeah, very good. Okay, so once you look at that, right, once you turn it into that, then you can just focus on this one, right? Looks much easier. And then we want to find x now. Okay, so now you need to understand what does the 4 over 3 mean, right? When you have an exponent, that is a fraction. Okay, you right? What does it mean? 4 over 3 as an exponent.
I don't know.
A fraction exponent, should we review?
Oh, it's like the square root thing.
Yeah, so what kind of root then?
Cube.
Cube root, very good. And then what's inside?
X to the power of 4.
Yes, very good. Okay, so that's what it actually means, right? You can check I think the first page of the chapter here, right? We did a quick review last week. Equals 16. Our goal is to solve for x, right? So we need to get rid of the cube root. We also need to get rid of the fourth, right? The fourth power. So what should we do then to get them away, right? Anyone? How do we get rid of the cube root and fourth exponent? What should we do? Donna, what do you think?
You put root 4.
Okay, so fourth root.
Fourth root over inside is 16.
Okay, so fourth root and then 16, and then
And then cube root x.
cube root.
No. Wait. Yeah.
You put another cube root, so like this.
No.
Oh,
Like the other side.
on the other side. Okay, so the other side is cube root
X.
x, like that.
Yeah.
Okay, okay, so right now at least we got rid of the fourth, right?
Yeah.
Okay, and then how do we get rid of the cube root then? Can anyone take over from here? How do we get rid of the cube root now? Cindy, what do you think?
Oh, I instead of doing like that, I just like did 16 to the power of 4 over, cube, and then cube rooted.
16 to the power of?
Wait, I forgot if I did 4 or 3, but yeah.
16 to the 4 over 3?
And then cube root.
And then put a
Wait,
cube.
no. 6. Wait, I got 8 though. Instead of like going from that, I just like flipped it over.
Flip which one over?
The 4 over 3, I just moved it to the other side.
Or move it to the other side, and then you put 16 to the
16 cubed, and then square, not root to the power of 4. I don't know how to say that.
fourth root. Fourth root.
Yeah, that.
Okay. So you mean 4 through and then like this cube?
Yeah.
Okay. Okay. So the cube that you have is to get rid of the cube root on the x, right? So basically you need to do the opposite of whatever you see on the left side, right? You have a fourth, so you do 4 through. Look at the color, right? The 4 on the left side, you need to do 4 through. You have the cube root. To get rid of cube root, you need to do a cube, right? So you need to do a cube. Okay? And then in other words, right, the cube means the numerator in the exponent, right? And then the 4th root is the denominator. So in fact, the x will be 16 to the 3 over 4. Okay, 3 is the cube, 4 is down here. All right, and then if you simplify this, okay, 4th root of 16 is 2. 2 to the 3 will give you an 8. Of course, this is taking too long, right? But I'm just trying to explain where Cindy's answer comes from, right? So you have 4 over 3 in the beginning, right? If you want to get rid of 4 over 3, you can bring it to the other side and then write the reciprocal, right? You flip the fraction over. And then once you get a fraction, then you will know that the 4 is the 4th root, right? Cube is to the power 3rd, right? And you find the answer, okay? So of course, when you are actually doing the work, you should go this way faster, right? Directly bring the exponent to the other side. Any question? Okay, can you raise your hand if you understand this part? You right? Samantha, do you get it? Okay, so next time when you see like 5 over 2, then you bring it over, become 2 over 5. Okay, you just bring over. Of course, they will give you a question in log. So first you got to turn it into log form, exponential form, and then you can isolate x. All right, so that's the first question we have here. Let's do one more, okay, on the right side. Okay, question B. So same thing, we will start with changing into exponential form. Okay, what's this one in exponential form? Tiana?
9 to the power of x equals to 3 root 3.
Yeah. Okay, so this 3 root 3 is not cube root, okay? This is 3 times square root of 3, all right? So this is a bit different, right? Different from question A. Question A is missing the base, right? The x, you take a look at the x. X is in the base, right? And then you can move the exponent over, right, by reciprocal. Now question B is missing the exponent. So you have to think about same base now. What we learned last week, right? They all got to do with base of what, Ire?
3.
Yeah, base of 3. Okay, so I'll let you try this out. Find out what x equals, all right? So when you get the answer, please raise your hand. So once you turn into exponential form, then you think about whether you can do same base or not. Remember, you can only drop the base once you get to 3 on the left side and then 1, 3 on the right side, okay? Then you can drop the base, okay? Don't drop too early. Okay, Eric, what's your final answer?
X equals 3/4.
3/4, okay. Cindy, how about you?
The same.
Same. Ire?
Same.
Tiana?
Same.
Yeah, okay, so looks fine. Okay, so I'll just quickly go over this part. 3 squared, right, to the x. So that will give you 2x. Right side will be 3 times 3 to the half. Right, so that will give you what? 1 plus, so 3/2. Right, and then drop the base. So 2x equal to 3/2. Then that will give you 3/4. Okay? Very good. You guys got the remember how to do same base. So I'm going to just pick 2 questions here, okay, and then let you try. Actually, let me see. 3 questions. Okay, question A, C, D. All right. So same thing. I'll leave that to you guys. Change it to exponential first, and then solve for x. All right. So if you finish all 3, please raise your hand. Okay, does anyone have questions so far? Okay, just try your best, okay? If you don't know anything here, right, do as much as you can. Once you try them all, then you can raise your hand, okay? And I'll see like any part that you need help. All right, let's get some answers first, okay? All right, Cindy, what do you have for question A?
16.
16, okay. How about E-Ray? What about C?
-5.
-5, all right. Anyone got different so far, the A and C? Okay, Tiana, how about question D?
11 over -5.
11 over -5, all right. Anyone got different for D? Eric, do you have the same for all three?
Yeah.
All the same, okay. Okay, let's check the steps then, okay? So first one, counter clock, right? So x to the power over 4 equal 32, right? We do counter clock. And we can do what we just learned before, right? When you're missing the base, you can just bring the exponent to the other side and make it reciprocal, okay? It will be faster. So it'll be x equal to 32 to the 4 over 5. And what does that mean then? Ray, what does 4 over 5 mean?
Square root with like the 5 in front
So
of
we
it.
call that fifth root.
Yeah, fifth root.
Yeah.
And then 32 to the power of 4.
Okay, so we can put the 4 on the inside or outside. Doesn't matter. I will prefer to put it outside, right? Because it makes the number smaller first. So fifth root of 32 is 2. So 2 to the 4 give you 16. Okay, that's very good. Okay, what's the counter clock for question C? Tiana?
7 to the power of x plus 3 equals to 1 over 49.
Yeah, very good. Okay, so this one very clearly, right? It's a base of 7, right? So how do I change them to base 7, Eric?
You change 1 over 49 to 7 to the power of -2.
Yeah, okay. So 7 to x plus 3. Now we can drop the base. X plus 3 equal -2. Then I'll give you this. Okay, so far you guys are doing good. Okay, last one. Question D. The counter clock for this one. Cindy, what do you have? What's the counter clock for this one?
Oh, 2 to the power of 16 equals 32 to the power of 1 minus x.
Yeah, okay. So we got to do same base now. Okay, so Donna, what's the same base here?
2,
Okay, so 2 to the 16, 2 to the what?
5,
5. Okay, so let's multiply in quickly. So 5 minus 5x. And let's drop the base. 16 equal 5 minus 5x. So for x, looks like it's gonna be that. Yeah, okay. Oh, good. So this is a very basic log equation, right? An equation that has log inside. So it's not really working with log, right? All we did is change it into something that we know, right? Change it into exponential. But sometimes there are questions that you cannot change. an equation you still need to solve for x, but you couldn't change into exponential, then what should we do, right? So an example of a question will be something like this. You have more than one log, right? We couldn't change into exponential. So we need something to work with more than one log. So that will lead to our next part. It's called log laws. Okay, so we'll learn how to simplify log, and then using the, once you simplify, then you can do counterclock. Okay, so each of the log law came from different exponent law. Okay, so we'll quickly prove each one of them and then learn how to use it as well. Okay, so first let's look at the top. Okay, the very top here. X equal b to the m, right? I want you to change each one of these two into the log form. Okay, so can you write out the log form for each one? And when you finish, raise your hand. Okay, so write it in the box on the right side. Okay, turn them into log form. So for example, the first one, what's the log form for the x equal b to the m? Cindy, how do you change that into log form?
Log base b x equals m.
Yeah, very good. Okay, so you go counterclock, but remember you got to start with the base, right? Base, and then because this one is written in the opposite way, right? B m equal x. So you have to go b base b of x equals to exponent. Okay, and then array. How about the second one?
Log base of b to y equals k.
Okay, you can say log base b of y, okay, equals to k. That's how you can say this out. All right, so now you got the log form for each one, okay? Let's look at the exponent law on the left side. This one is adding the exponent, right? We're adding up two exponents here. We will be adding exponent if they are multiplying, right? Remember from the exponent rule, so equal to b to the m, right? Multiplied by b to the k. Any questions so far? Right? It's going backwards, right? B to the m times b to the k is b to the m plus k. And then looking at the top, the yellow highlighted, okay? B to the m is x. B to the k is y. So I'm going to replace it, okay? So b to the m plus k is x, y. Right? This is the exponent in the red box, right? The other side is x, y. Any questions? Okay, I'm just replacing it with x and y. And then after this, I'm going to do counterclock. Okay, counterclock. Turn this into log form. All right, so how do I write this out into log form then? Eric?
Is it log log of b
Base
oh yeah, log base b of x times y equals m plus k.
Yep, equal n plus k. Okay, so everybody please write this down. Right, all we did is change it into log form. Counterclock. Once you turn into that, then let's take a look at what's m, right? So now please look at the right-hand side. The yellow highlighted on the right-hand side, we have m is log x, right? K is log of y. Both of them have same base, okay? So it will become log base b of xy equals to log base b of x, which is m, plus log base b of y, right, which is k. So that's how they figured this out, right? The formula on the top, okay? So I'll highlight that formula, or formula number 1. So what's the use of it? Okay, what's the purpose of this one? So for example, if you see, let's say log base 2 of 8 plus log base 2 of 4. Right? You have 2 log trying to add, right? And then you look at it and then you see, oh, they have the same base. Then there must be a log, right? 2 log they can add together and then it becomes multiplying. Okay? So let's take a look. If I apply the rule and put it together as 1 log, what's the new expression then? Tiana, what do you think?
Log 2, 8 times 4.
Okay, 8 times 4, we can do that in the head, right? What do you get?
32.
32, yeah. Okay, so the answer will be this one, right? If you simplify it. Now, if I want to find out what this thing equals, right? What's log base 2 of 32? Then what you can do is, in your head, you think about counterclock, okay? You start with 2, right? Start with 2. 2 to the what exponent, right? Remember this equal to something, right? 2 to what exponent can give you 32? What's the exponent? Oops. Okay. I got shut off. Okay, give me 1 sec. I think it's too much learning. The application just turned it off by itself. Okay, can you tell me what's the exponent then? 2 to what equal 32? Donna?
2 to 5.
2 to the 5. Okay, so let's wait. Okay, I'm still waiting for the document to load. All right, here it comes. I think probably because I zoom in too much. Okay, so this one is 5. Okay, let me zoom out. Okay. So this part, okay, can you raise your hand if you can see the screen now, all right? Can you raise your hand, please? Yeah, if you can see the screen. Okay, so you do counterclock and then you figure out, okay, the log base 2 of 32 will equal to 5. Okay, you do that in the head. So equals to 5. So the left side, log 8 plus log 4, right? With base of 2, the answer will be 5. So that's the use of it, right? Without using calculator. So you use the log law, our first one adding, it will become multiplying. And remember, it will only become one log, okay? So let's look at second rule now. Second rule is for subtraction, okay? So this time we can do a bit faster, right? It's the same idea. Subtracting exponent will become dividing, right? So b to the m divided by b to the k. And just like before, right? B to the m is x, b to the k is y. And left side is m minus k, right? Same as before. And then we will write it out in counterclock, right? Into log form, counterclock, like that. So what does it become this time? Tiana?
Log b x over y
Yep.
equals to m minus k.
Yep, n minus k, very good. And then n minus k is just log x minus log y with same base, right? Base b and base b. Okay, so that's our rule number 2, which is already up here, okay? I'll highlight that. And the use of it, okay, so this time let's try to combine the first one and second one together, right? So I could have something that's adding, okay, let's try a different base, okay? I have a 3 and 9, okay? Minus log base 3 of 1/3, right? And then plus log base 3 of 27. All right, so can you guys try it out? Simplify this one. Subtracting means you need to do dividing to combine, right? Adding means you need to multiply to combine. All right, so please combine it together, turn it into one log, okay? And let me know what's inside the brackets. Okay, raise your hand if you have the final answer in the brackets, all right? Subtraction means dividing. Adding, it becomes multiplying, okay? Okay, so inside the bracket, what would it be? Donna, what's inside?
729.
729. I think it's too big. Are you sure? 729. Cindy, what do you have? Do you have 729?
I just wrote 9 over 1/3 plus 27.
Should be multiplying, plus will become multiplying. Right? If subtract means divide, right? So if you want to write it out separately, it will look like this: 9, right? Over means divide over 1/3, and then times it by 27. So multiply 27 like that. Is it 729? Eric, what do you have?
I have 729.
729. Okay, so pretty big here. Okay. Cindy, how about you?
Yeah,
Yeah.
I
Okay.
did solve it that part. Yeah.
Okay. So remember, subtract means dividing. So when you divide by 1/3, it becomes multiplied by 3, right? So actually, it becomes really big here. All right. So 729. Now, if I want to find out what that equals, you do the same thing, right? Counter clock, right? 3 to what can give you 729?
6.
6. Okay. So answer, if you want to evaluate, right? This answer will be evaluate. This answer is for if they say simplify. Okay. Well, sometimes they say simplify, you have to go to evaluate. Okay. So let's erase that. Okay. Evaluate or simplify. Okay. So either one, if possible, then you go to 6. If it's something that you cannot find out the final answer, you just leave it in log. Okay. All right. Next rule is for the multiplication one. Right. So b to the m times n. Right. When you multiply exponent, so think about when do you need to multiply exponent. You would have b to the m and then another exponent outside, right? Then you will multiply the two exponents together. Okay, b to the m. b to the m was the x, right? So we'll write it as x to the n, right? And then b to the m times n. Okay, so this is our exponent. This is our other side. Okay, so we are doing the same thing. I want to turn this into log form, okay, by counter clock. So how do we change this into log form now? Can you tell me, Eric? What's the log form for this one? Eric, are you there?
Oh, yeah.
Yeah. How do you change this one into log form?
Log base b of x is powered n equals m times n.
Yeah, m times n. Very good. Right? And m, look at the yellow highlighted on the top right corner. M is log x, right? Log of x. So I can write it as log base b of x times it by n. Or you can just put the n at the front. Okay, put it at the front is better. Otherwise, it feels like it's x times n, but it's not. Okay, it's n multiplied by log x. So this whole thing is together. Okay. So what's happening here is when you see an exponent on the inside, you can bring it down to the front. Okay, drop it down to the front. So for example, okay, let's look at an example on the side. If I have, let's say, 2 and 8. Okay, without doing anything, just looking at this, what do you think the answer is? Tiana, what do you think this equals? If you want to evaluate.
3.
Equals to 3. Okay, how about you? Cindy, what do you think?
Yes.
Yeah, okay. So you can think about 2 to something equal to 8. So this has to be 3, right? Now let's look at this same question differently, okay? Try to use this third rule. So I write this, right? Keep in mind the answer is 3, okay? And then we'll try to get that answer differently. the 8, I can write it as 2 cubed. Correct? Right? So take a look. Right? Now we have an exponent, right? Exponent of 3. So because of our log of power, right, the third rule, I can drop it to the front. So I would have a 3 at the front, and then log base 2 of 2 now. Okay, 3 is no longer on the exponent, it's going to the front. And then we can take a look, right? What's log base 2 of 2 equals? Donna? What's log base 2 of 2?
1.
Yeah, equals to 1, right? 2 to the 1 will be 2. So this part is just 1. So you get 3 times 1, which is 3. Okay, so that also shows you that your initial answer is correct. Okay, also shows you the rule works, right? This exponent. So remember, if you see an exponent, you can drop it to the front. Okay, if you see a subtraction, you can make it into divide. Adding can become multiply. Okay, now some little notes on the side. Okay, you can write it on the, I don't know if you have space. Okay, you can write it on the top here. Okay, so log x times y, not log y, does not equal to log xy. Okay, this happens a lot. Okay, there's no rule for multiplying log, no rule for dividing. Okay, so etc. Right? So log x divided by log y, we don't have such thing. Okay, so it doesn't equal to log x over y. So just make sure, don't invent your own rules. Okay, you only have adding, subtracting, and then the exponents. Okay, let's try a few questions using these 3 rules. Okay, and then next class, we'll talk about 2 more, or actually 3 more rules down there. Okay, those are the easier ones. Okay, so let's try these 3 questions. Any questions so far for the rules? Okay, so we'll look at question A. Kind of summarize what we just explained over there, okay? So I'd like you to evaluate, which means simplify as well, okay? So you go all the way, you get a single log, and then get the final answer, okay? So when you finish question A, please raise your hand. So your final answer should be a number. Okay, no log. First, you simplify it using your rules from last page. Simplify into a single log. And then evaluate the answer. Okay, raise your hand if you finish or you get stuck, okay? If you are confident, of your answer, you can move on to B, all right? Expanded form just means the once you separate it, okay? This is called expanded, okay? Let's check the number inside the bracket first. So Cindy, what do you have inside the bracket?
16.
16. Eric, how about you? Do you have the 16 on the inside?
Yeah.
Yeah. Okay. And Ray, what's the final answer then?
2.
Yeah, very good. Okay, you can do counterclock, right? 4 to something will equal to 16. So 4 squared has to be 16, right? So equals to 2. Okay, now for question B. Expanded form means you turn everything into add and subtract, right? So no dividing anymore, right? No divide, no multiply, and no exponent. Okay, so if there's an exponent, you have to drop it down, put it at the front. Okay, so using your third law. Okay, so you got to use the first one, second one, and third one here. Okay, so going backwards. Okay, here let me show you the 16 a little bit more, right? So like over here, adding will be 6 times 64 over 3. Subtract means divide it over 8. Okay, and that will give you log 416. Okay, erase this. Okay, and finally you get 2. So what you're trying to do in the expanded form is to go backwards, to go from here to there. Okay, go from the big bracket inside and go back up. All right, so once you finish the expanded form, please raise your hand. This one has a bigger space, okay, because there are some common mistakes that could happen. So I want to go over, okay? So I'll get a few answers from you guys. Doesn't matter right or wrong, okay? So if you finished or you got something written down, you can raise your hand, okay? Give it a try. Okay, Donna, do you have anything down?
Yeah.
Okay, can you tell us what you have so far?
Log x subtract log 2y to the power of 3 and then equals to log x subtract log 2 plus log y to the power of 3.
Anything else? That's all?
Yeah.
Yeah, okay. Does anyone want to add to that? Or anyone got something different? Cindy,
Yeah.
E-Ray, yeah, what do you have?
The same, but put the 3 in front of the log.
Okay, so let me add one more step. Okay, yeah, using the third law, we could bring the exponent to the front, right? Because make sure no exponent in your expanded form, right? That's what it means by expanded form. Anyone else got something different? Tiana, how about you?
No.
The same. Okay.
Yeah.
Cindy, how about you?
The same.
The same. Eric?
The same.
The same. Okay, so that's why I say this one is a common mistake. Okay, so this one is really close, 90%. Almost perfect. Think about it. Why? Which part did you forget to do it right? Give you another chance. Let me know, okay? You can say anytime if you can point out which part that we forget to do.
Wait, is it something to do with brackets?
Yes. Yeah, you can say that, yes. Where should we put the brackets?
With the log 2 and the 3 log y.
Yes, okay, because the two, very good, okay, very good, Yuri. Because this 2y cubed, they are both inside the second log here, right? So they are like together, right? 2 and y cubed. So when we are doing adding, we should start by writing out, okay? So this one is, you can write down this way is the wrong way, okay? So you can remember, right? So this is the correct way. Okay, so be careful with the bracket and let's see how that will affect your final answer, okay? So I will have log x minus log, right? 2y cubed, this is all the same, but remember these are together. So when you are expanding it, 2 plus log y cubed, these two are still together. Okay, that's the difference. We forgot the brackets when we split it into adding, right? So your next step, right, we can bring the cube down. How do we get rid of the bracket then? Eric, how do we get rid of brackets?
Change the sign.
Yeah, okay, so the negative, the minus on the outside will affect the sign on the inside. So it'll become minus 3 log y, okay? So the minus sign, this is the key, right? Before you had plus. So an easy way to remember is if you see if it's down at the bottom, right? Look at the yellow part. Oops, wrong color. Okay. Yellow highlighter here, right? The denominator, whatever that appears in the denominator, and then it will be the subtraction, right? If it's in the numerator, then it will be positive, okay? Then that will be the easy way to remember. Then you don't have to go through brackets, right? You can go straight to final answer, right? You see a 2 down there, you know it's subtract log 2. You see a y cube, so it's subtract log y cube. Okay? Last one, okay? Last one, this one is going backwards, okay? And then we are going from expanded form, right? Expanded form back into single, okay? So please try this one out. So you want to put all the exponent, all the add and subtract back into where it belongs, right? So your final answer should be a single log, okay? Please raise your hand if you get a final expression. So when you go backwards, you think of the same way, okay? If you see a subtraction, that means it goes to denominator, right? If you see an addition, it should go to the top, okay? And the number in front of the log, they become the exponent, right? They came from exponent. Okay, please raise your hand if you finished. Anyone? Any questions? Donna, Samantha, Tiana, how are you guys doing? Okay, Cindy, what do you have inside?
Like final answer?
Yep, final.
A and then root 4C.
Say that one more time. A and then
Root 4.
so fourth root.
Yeah.
Like
Yeah. And then C over B.
over B. Okay, anyone got different? Donna, what do you have? Donna, do you have the same?
No, I got a to the power of 4, and then the rest are the same.
So fourth root C?
No 4.
No 4. So square root C
Yeah.
over B, like that? Okay.
Yeah.
Okay. And Tiana, what do you think? Are you done?
No, I'm not sure how to do it.
Not sure how to do it. Okay. You go backwards, right? So if you see any number at the front, you put it back into exponent first. Okay. And then once you put everything back, then you think about adding become multiply, right? Subtract become dividing, right? Because we're going backwards.
Wait, Jason, I read my answer wrong.
Yeah. Well, what's your answer now?
The same as Donna's. I just read it wrong because I was doing the next question. Yeah.
You were doing the next question?
Yeah, so yeah, but I got the same as Donna's. I just read my answer wrong.
Okay. All right. How about Ray?
Same as Donna's.
Same as Donna. Okay, let's quickly go over how to get Donna's answer then, okay? All right, so let me erase that. Okay, so first step, you should bring all the exponent back to where they are, right? The 1/2, you bring it back, okay? So it will become log a to the 4, right? Using the third rule backwards, right? Minus log b plus log c to the 1/2. And c to the 1/2 is root, right? Now, all you need to do is draw a line, and then if it's subtracting, that means it goes to denominator, right? A to the 4 is positive, right? At the front is positive, so it will be on the top. Minus log b, so that means b will go to the bottom, okay? Adding means it will go to the top, right? Because multiplying. So it'll be c to the 1/2. C to the 1/2 is the root, square root of c. Okay, do you get it now, Tiana?
Yes.
Yeah, okay. So I think that's it, all right? If you have any question about anything on today's lesson, okay, you can stay after class. And then I'll send you the homework later, all right? I'll see you guys on Friday.
Bye, Jason.
Okay, bye, Ray.
Bye.
Bye.
Bye. Have a good night.